Did you know that over 5 billion people worldwide are connected to the internet? It's astounding when you think about it. Whether we realise it or not, we're all part of the vast, intricate web we call the internet. It's woven into the very fabric of our daily lives. From the moment we wake up and check our phones, to streaming our favourite shows, booking train tickets or ordering groceries online, most of our interactions with the World Wide Web happen seamlessly and often without a second thought. It's probably how you're listening to this right now. These connections to a global network of computers and servers keep our modern society humming along 24/7, 365 days a year. But behind the magic lies a massive infrastructure, data centres filled with servers, cooling systems and miles of cables. This is the unseen world that keeps our digital lives running smoothly. And like any large-scale operation, it has an environmental footprint. Imagine a country whose borders span every continent, its citizens connected by invisible threads. This country consumes more electricity than Russia and is only surpassed by the US and China in its hunger for power. This is the digital world that we live in. From sprawling data centres to the networks that connect our devices, the energy demand for our online lives is staggering. Each Google search, YouTube video and cloud backup requires energy, much of which comes from fossil fuels. Today, we're diving into the environmental impact of this behemoth and how the cloud, an integral part of our internet infrastructure, is both a challenge and an opportunity for a greener future. In this episode, I am delighted to introduce Sophia, who's joining us from New York. So you may hear a bit of hustle and bustle, coffee shops and taxis rolling by, but it just adds to the atmosphere. Welcome, Sophia, to the show. Thank you so much for joining the Core podcast. Would you like to introduce yourself to the audience and give us a bit about you and your background and experience?
Yeah, sure. Thank you so much for having me. My name is Sophia, and I'm a software engineer based out of New Zealand. I'm coming up on 8 years of experience in the industry, currently working at Rye, where we build tools for developers to add e-commerce functionality to their apps. And prior to that, I was the engineering manager for the AI team at Crimson Education, which is a college admissions consulting business. Today, we're talking about green software engineering. I've been passionate about climate change like my whole life. I found out about climate change in primary school, and it was particularly devastating to me. I thought that the world was going to end. And I knew at that point I wanted to do something climate related, but I wasn't entirely sure what. I had worked with computers with my father, who was like in the industry, and so I sort of went with that as like a path of least resistance. And like as I've grown older, I've sort of realized that software has this really large climate footprint that so many people are not aware of. We kind of think of software as being inherently very green and clean, but in reality, there's this big iceberg beneath the software industry, and it's imperative for us all to make better design decisions when we're making software and building things in a carbon-aware fashion, because it does have a surprisingly large climate footprint.
Yeah, and I think we don't really consider that. Like, I definitely don't. You just assume, well, it's in a cloud and it's not in a physical building and we haven't dug something up to build it or ripped down some trees to create it. So you don't really think of it like that. So if we start at data centers, so we know they're the big engines, they're connected to the internet, they power everything we're doing online. What is the kind of the energy needed for that and the demand for that? And what does that kind of look like if we can visualize it in some way for anyone listening?
Yeah, sure. So data centers are really, really energy intensive. So if you just think about like the scale of the operation, I remember in high school reading a Wikipedia article talking about Google reaching their 1 millionth server, and this was in the 2010s. And the rate at which we've added servers to data centers, not just at Google, but at Amazon, Microsoft, like all of the hyperscalers, has only accelerated since then. So there are millions and millions and millions of servers running in these data centers, and every single one of these servers requires energy. Hopefully, this energy is coming from sustainable sources, but there's not 100% coverage there. And so in 2015, like to put a hard number on it, global data centers were about 2% of the world's total electricity demand. 2% doesn't sound like a lot. It's a fairly small percentage, but if you think about all of the energy used like globally by all the 8 billion people on the planet, like 2% is quite a bit of energy. And there's huge infrastructure required in order to generate the energy we need for this demand, like huge power generation.
And we're talking about studies that were done 2015, 2012. A lot's changed now in 2024. Like, technology's evolved so much during that part. Like, we're using internet more. It's plugged into everything, into our cars, into all aspects of life, right? So to think it's 2%, I would say, I guess it's a lot higher 10 years on. We just don't have the research or the papers on that yet. So data centers are incredibly energy intensive. What innovations are you seeing in this space that's going to make them more efficient?
Yeah, so I think like we can think about this at like a few different levels. Like the one that people are going to be most familiar with is just like where you get your power from, whether that's like a coal-fired plant or a hydroelectric dam. And obviously the latter is much more climate friendly because in the case of the hydropower, like you're not burning coal and emitting carbon directly into the atmosphere. And so, like, all of the major data centers have been shifting their energy generation off of, like legacy energy sources, I guess, and onto more sustainable sources. The distribution of this is kind of like uneven. So if you were to look at like Google Cloud as an example, the Los Angeles and Las Vegas data center regions are pretty close to each other geographically, but the LA region, about 55% of its energy comes from like what we call carbon-free energy sources, whereas like the Las Vegas data center is only 13%. So as consumers of these data centers, like it's worth doing a bit of due diligence before you deploy your application and figure out like which region is the best. This is like the easiest for us to reason about, but like there's been a lot of investment here on the hardware side. In large part because like there's a big economic incentive to do so, but like hardware today is significantly more efficient today than it was in 2015 when that study first came out, and it really starts like back in 2009. Like there's this big bifurcation in data center design as Google and the other hyperscalers start to build their own servers in-house. If you look at like a server you might get from the computer store down the road, you'll notice it has a lot of like personal computer style components in it. It will probably have a disk drive, for instance. And in a data center, you don't need an optical disk drive. It just takes space, it reduces your compute density, it draws a little bit of extra power that's not used for anything productive from the perspective of the data center. You'll see like an individual like power supply in every single server, and that conversion from AC to DC is very costly. And so what you will see in like a modern data center is every single component of the server has been engineered to reduce the amount of energy it requires to run. And the incentives are really well aligned here from the perspective of the data center. The less energy their hardware requires, the better their business model is, right? Like the economics improve as your energy demand reduces. And so there are all kinds of innovations in this space. Like for instance, like modern content delivery networks will cache data directly on the network card in order to avoid hitting disk or memory in the first place. And for the longest time, like this kind of hardware was not really available to those of us working outside of Google, Microsoft, etc. Recently, there's a company called Oxide Computer who are, um, trying to bring this kind of server hardware um, to the masses, so to speak. Obviously, there's quite a big bill. If you're doing something very small, this doesn't make sense. But for people who are interested in running their applications on-prem, either because the cloud is cost prohibitive at their scale, or they have regulations that they need to keep in mind. Um, Oxide's offering is particularly attractive here relative to off-the-shelf consumer hardware because it has been designed from the perspective of people who have experience working in these like really large data centers and really like squeezing everything out of the hardware.
So it's amazing to see that the impacts happening and things and small efficiency changes can have a big impact on energy. I mean, I don't know, did you have huge energy bill spikes last year in New Zealand and
Um,
America, or was it just the UK? Because ours spiked massively.
Yeah, the Ukraine war that wasn't very good
Helpful.
for energy prices in Europe.
Yeah.
And in New Zealand, like we're actually relatively self-sufficient here. Like we have a lot of
Mm,
hydropower and quite a bit of wind, and so we
yeah.
didn't really see too much of a difference in energy prices. But yeah, certainly in Europe, it was pretty wild.
But hopefully that is making businesses in the UK make sure that they're being as efficient as possible, like with the dark with the light, right?
Mm.
Where if we saw our energy rising, all of us lowered using less, it's got to be, hopefully have a big impact. Moving away from just talking about hardware, let's talk about software, and how the improvements could be made and how this could impact the carbon footprint there. So what kind of examples and things are you seeing from the software side of things?
Yeah, this is a great question because I think like the data center side of the equation, like people understand when they look at one of these buildings, like it's this big glass and steel
Yeah.
enclosure. People see that and they intuitively understand, like, hey, there's quite a bit of there are quite a few like climate externalities here. Um, Software is invisible. We don't really
Mm.
see what's happening here. It's very abstract. And so, like, if we think about this from first principles, like if we think back to high school physics class, we're learning about thermodynamics. We know that, like, there's no such thing as a free lunch. We can't create
Mm.
energy out of thin air. We can only transform it from one form to another, and there's always some loss factor here. Um, and so every line of code in your system is going to have some carbon emission equivalent because you require energy in order to run this code in the first place. And so if you internalize that, it's pretty easy to see that like software that is more efficient, that does more work and less instructions and less time, is going to have some impact on our society's emissions. And what I think is like particularly exciting here is that when we make our software systems more efficient, it doesn't require any lifestyle change on behalf of like people in society, which we know empirically is very difficult to achieve. Um, two examples that I can give is the first one is PHP is the language that powers something like 50% of all websites. It's really ubiquitous.
Okay.
And in 2015, 2016, sometime there, version 7 of this language released, and Rasmus Lerdouf, I hope I pronounced his name correctly, who is the creator of the language, gave a bunch of talks about this. And the headline feature of PHP 7, among other things, but the big one was it was significantly faster and more efficient than previous versions of the language. Like they invested a
Right.
lot of engineering effort into making this language work faster. Um, and he'd done some like back of the envelope calculations at the time and had suggested that like if everybody were to upgrade their websites running old versions of PHP to the new version, PHP 7, it would save something like 7.5 billion kilograms of carbon emissions every year. And that
It's a lot.
number is a little abstract. People might not
Yeah.
understand what 7.5 billion kilograms of CO2 means, but it translates to roughly like 10% of New Zealand's entire emissions in 2021. So it's pretty significant. Like you cut off like
Yeah. It's a
10% of a developed nation, and nobody had to go, spend a ton of money on like an electric vehicle. Nobody needed to change their diet. Nobody needed to defer travel plans. Like we got that saving completely for free because a bunch of people, wrote code to make it happen.
The other example that I've also got in here is Uber's, and that they fine tuning of their Go garbage collector saved about 70,000 CPUs. Could you explain that one a bit more to me?
Yeah, so this happened in 2021. And so Go is a very popular language
Okay.
in like modern software stacks. Not quite as popular as PHP, I would say, but it's one of the main ones. Um, and Go, like most modern programming languages, is a garbage collected language. And garbage collection is great. It's been a huge win for security. Like the number one source of security issues comes from buffer overflows, which are notoriously easy to introduce in your code when you're manually managing memory in systems programming languages. But the big
Okay.
downside of garbage collection is it's this automated process running in the background, which manages memory for you, and you don't have the same level of control over this process as you do when you're managing memory manually, which means that garbage collected languages like Go are less efficient from a climate perspective than something like Rust or C++. And I believe actually that Amazon have put out research a few years ago where they looked at like, for each of the 10 most popular programming languages, like which is the most like climate friendly. I forget where Go sits in the list, but it's in with all the other like garbage collected languages.
Okay.
And so garbage collectors, you can tweak parameters on them in order to change how they behave at runtime. And Uber is at like a level of scale where a small improvement in garbage collector performance yields like a really big delta to their infrastructure footprint. So in 2021, they published a press release talking about how they'd tinkered with the garbage collector. Unfortunately, it was a largely manual process. They didn't like develop an AI solution that everybody can use. But the net impact of that was they saved like 70,000 CPU cores. If you think like maybe a server has, 16 cores or something, that would correspond to like 4,000 servers freed up that they're no longer using. Potentially someone else has used them, but like getting 4,000 servers, reducing your server requirement by 4,000 nodes is pretty big, right? I think like
Yeah.
most people listening probably are not working on systems which involve like 4,000 servers. At Rye, we're not quite there yet. So it's like, hundreds of small startups essentially that Uber has saved here.
And yeah, like you
Um,
said, it's just stripping back waste, isn't
mm,
it? Removing stuff that's not needed and making everything way more efficient.
mm. When we talk about these two examples, and these are like the two that are sort of like at the top of my mind anyway, they're the two talking points I always go to, Uber and PHP 7. Something that's like worth touching on here is, the PHP 7 upgrade came out in 2014, 2015. Uber released their press release in 2021. And I think that speaks to like how little attention there is on this topic just in general. Like there's really not that
Mm.
much going on. And so I think it's like really important to build awareness here, and there are industry groups that are quite interested in like pushing this work forward. Anyone who's like interested in digging deeper here, there's an organization called the Green Software Foundation, and they have like a certification you can take to demonstrate your understanding of this stuff, and like practical guidelines for thinking about the carbon efficiency of your software systems, and like best practices for how to engineer um, uh, better and more climate friendly software solutions.
Like you said, there's not been many stories or recent press releases or things that have come out. Most of them are kind of within like a 10-year ago. Climate change, as I feel, is being discussed more and more. Why do you feel there's not, obviously we've got to guess why, but why do you think there's not been a bigger drive or more stories yearly? Like surely they saved
Mm.
cost for making their stuff more efficient. Do you think it's just not the appetite? Do you think there's not the legislation? Or do you think it's not forcing people to become more efficient and think about their impact?
Yeah, it's a great question. Like I think there's probably no like one correct answer here. It's probably like a
Okay.
combination of multiple things. I think like when you look at like the automobile industry, for instance, like
Mm.
it's very obvious when you see like a big truck like hurtling down the highway, exhausting fumes. Like it's very obvious to us, like, hey, there's there's a climate impact here.
Mm.
And when we think about like consumerism, right, like fast fashion and things like this, like it's very obvious to us, like we purchase this thing, it gets shipped to us, and we intuit like there is a climate cost here. Software is kind of like it's not tangible. We don't see it. We're very separated from data centers, and so I think like honestly, like a lot of climate tech improvement, like probably comes from consumer demand. Like I think people
Consumer. Yeah.
want more efficient vehicles. I think people want more efficient like courier and order fulfillment networks. Like this is very tangible. It's very real to us. We experience it every day.
Mm-hmm.
Whereas we just don't have that same, like, there's not that same physicality with software. And so, like, consumers are not talking to, the companies that build the software they use and asking them, like, hey, what is your position on
On
the
this.
climate? Like, what are you doing
Mm.
here to responsibly manage your climate footprint? It's just not really something
Mm.
that's coming from consumers. And I think like there are two other things that are probably worth touching on. Like one is that like in absolute terms, like when we're talking about the climate impact of software, to some extent, like this is a very long tail issue. Like if we were able to snap our fingers and immediately everybody's driving electric vehicles, we would achieve like a significantly larger climate footprint improvement relative to optimizing the world's software. And so I think like there's part of this is also like a prioritization question, like where do we
Mm.
invest our energy? I would argue that software is worth more investment on the climate front just because like the theoretical gains we get here are very achievable because they don't require people to make like lifestyle changes. Um, and it's just very difficult to convince people to make these lifestyle changes. So I think like although the absolute impact here is less than what we get theoretically from like mass adoption of electric vehicles and other initiatives like this, um, it's worth investing energy here because it's realistic, and like a 1 kilogram theoretical saving generally is going to translate into like an actual real world, like 1 kilogram of carbon saving. The other thing is like, historically, I think like, and culturally, like I would say that like software engineers are not very good at like self-regulating. It's a very new like engineering discipline, and something that like, this is not strictly related to climate, but something which really sticks in my mind is this blog article that I read like many years ago, titled like "The Code I'm Still Ashamed of." And this guy talks about how he was contracted by a pharmaceutical company to build like a quiz widget. And the requirement said that regardless of what anybody answered on this quiz, like the result of the quiz was always to recommend a particular drug to the person taking the quiz.
What?
And yeah, and the guy did it. He didn't think too critically about it. And I forget like how much time passed, but eventually he saw in the news that, and so it was an antidepressant drug, and one of the side effects of these drugs is a short-term increase in symptoms, which needs to be managed by your healthcare professional. And I forget like how much time passed between pushing this into production and the news article this guy wrote, but someone had killed themselves after taking this drug. And this guy was obviously in shock about this. He found out his sister was also taking this drug, and
Oh my
so
God.
there was like a personal element here as well. But like, when I studied software engineering at university, we never spoke about like ethics in engineering. If you become like a drug designer, you will hear all about the stuff that people did during like World War II, as an example of like, this is like extremely unethical behavior, and it's so easy as a professional to fall victim to this stuff. And so I think like just in general, like software engineers do not have a particularly great grasp on like the ethical responsibilities that come with our job. Most people get into this because like, and I'm in this group. Like I got into it because I like the tech and it's fun building on it.
Mm.
And at no point in my career have I ever like sat down and like been taught about like, hey, here are some of the second and third order effects of your work as a software engineer that you should keep in mind, whether that's climate impact, whether that's ethical considerations. Like these things are pretty absent in the field. And so I think like as an industry, we're also just not very good at like pushing for making this a big deal because it's not on our radar.
I mean, so much to unpack with that. But like the amount we use apps or we see adverts of, do you think you may have, or this app could help your life be better, or you could be more regulated with your emotions if you use this, or be a kind parent and this app will help you do X, Y, and Z, or so much that you trust and assume that you're completing these apps to give you the best results at what you want. But like you're saying, if at the background it's going to give you the same answer, whatever, because they want you to download the app, buy the product, or use it, there's a huge trust in that. There's a massive trust in that. And yeah, maybe it's a naive. I think this is the whole reason why the tech industry is so fascinating, because it's coming faster than we can create rules or regulations or things to control. Like the next segment we were going into was obviously AI. I mean, I've chatted on this podcast on loads of different reasons. I've got one up and coming, which I'm really excited to do, because it's about how AI can now create things like art and music and all these things, which are so in our DNA. Like we drew in caves, didn't we? And we communicated in that. That's culture. So if AI can do that, what impact is that on our culture as human beings? Where does that lie in the future? Blows my mind thinking about it. But yeah, you're now saying people are making decisions, and it's not till we've done something. And he probably built the code to make the best app or the best thing, and it was really efficient and he was really proud. Probably didn't even think about the impact 10 years later I don't know, maybe they didn't even tell them what drug it was recommending. They just asked them to code. Who knows? But he made something that was efficient, worked, did the job, gathered the data, and gave someone in a recommendation, right? That's probably where his brain was. Same with people generating AI, ChatGPT, all these things. It's to make the world a more efficient, better place. But there's a whole other podcast we could do on the rights and wrongs. But from an environmental impact, what do you think AI is? Is it a good light? Is it a dark light? What's it bringing to us?
Yeah, it's a great question. I think it cuts both ways. So I think there's obviously like a lot of attention on large language models like GPT. And these things are probably not so great from a climate perspective. I think from like a democratizing access perspective, like this is fantastic. Historically, it has been tremendously difficult to build like ML and AI systems. There's a paper from Google on their ML ops paradigm to managing these projects where, prior to this big like process change at Google, like they found that like 90% plus of their machine learning projects like failed to productionize because it's just so difficult. And so I think like there's a lot of hype around LLMs because you can just talk to this thing as if it was a human, and it gives you like really valuable output with so little investment on your part, especially relative to building your own custom models. But obviously, like the trade-off here is that these large language models, they're not called large language models for the hell of it. Like they are truly gigantic. So GPT 3.5, for instance, is 175 billion parameters. And what a parameter is it's like a matrix of numbers in a neural network. And the way these things work is you have some input data and it goes through layers of a neural network. You're multiplying, you convert the input from text into some like numerical representation. So if anybody's like tangentially across the space, you'll have heard like embedding vectors, which is the numerical representation we turn natural language into. And you push these numbers through a big neural network where you're multiplying them by these parameter values and applying like a non-linear activation function to them. And that non-linearity is where you get sort of this emergent and interesting behavior that we perceive as intelligence. And so, if you just think about that process of like performing a multiplication like 175 billion times to simplify the architecture here, like that's a lot of math. It's a big process. GPT-4 is even larger. Llama 3, which Facebook or Meta, just released, like this is a 400 billion parameter model in the largest variant. These things are really easy to get up and running with, but they're huge and they are wildly inefficient relative to those more classical machine learning models. So, the quintessential like machine learning problem is building a system that can take in a picture of a cat or a dog, and which will identify correctly like whether it is a cat or a dog. I've personally ran this workshop with a bunch of different groups. And this was a solved problem like a decade ago with SVM models, which could run on commodity laptops at the time. Like you think about how bad laptops were 10 years ago. Like we could solve this problem with those laptops at the time. And today, like you can upload a picture of a cat or a dog to GPT-4v or GPT-4o and ask it like, is this a cat or a dog? And it will give you the answer with a high degree of accuracy. But The difference in scale here is you absolutely cannot run GPT 3.5 or GPT 4 on a laptop that you can just buy down the store. Like, you require a big data center with a ton of GPUs to get this output. So I think, like, great for access, not so great for the climate, at least in terms of large language models. A lot of people are blindly using this technology because it's so easy to get a prototype up, and sort of discounting these traditional methods of building classifiers for these like simple tasks. I think, like, in general, though, there's a lot of focus on LLMs, but they're not like the field of AI is much larger than just large language models. So we have all these old like statistical models that are still available and still in use. Um, so I certainly hope that nobody is using GPT-4 to discriminate between photos of cats and dogs. You can
I
download
might do it later for
you can
fun.
download a model online that's much smaller and less
Yeah.
compute intensive. But in New Zealand, the university I went to, University of Waikato, has a project called Ahora, and it's this energy tech platform. So we've spoken a lot about like electricity use in the context of data centers, but another major source of emissions is through like industrial heat. And so,
Okay.
and this is like as simple as, boiling water to produce a coffee in a coffee shop, all the way up to like cooling big, industrial, cooling a data center, for instance.
Mm.
And so, what my university is doing is they have this research project which is all about like creating like digital twins to these real world systems so that you can simulate what happens if you make changes to how you're heating
Oh.
the liquid or the gas. Like, how do things change as you move things around in the system and tweak some design decisions. I think industrial heat is something like 30% of New Zealand's emissions. I could be a little off on this. That's coming to mind.
Mm.
Um, and this is all fundamentally like AI. You need a really smart AI model to simulate how do things change with respect to the energy involved in heating up whatever it is you're working with. And so I think like there are use cases like this where AI is going to be hugely impactful. Or, if we think back to that Go garbage collector thing, like
Yeah.
historically, garbage collectors have been tuned by hand. They're, static sort of programs that people write. And potentially there is a future where, we use AI to perform the kind of tuning that Uber performed by hand on their garbage collector. And we can do that autonomously and at scale, and it's as easy as everybody just like flicking a switch. So I think like it's a mixed bag. Like, I'm not terribly
Mm.
happy about large language models from the perspective of the climate. But I think like in the space as a whole, like there's a lot of like interesting work, and I think like on nets, like AI will probably be a boon to our climate endeavors.
It's interesting you talked about digital twins.
Hmm.
We are seeing that actually in the cyber industry, where especially in IoT and very much in medical IoT, in how we can make digital twins of that, say the MRI scanner, to then see what tweaks, what upgrades, what operating systems and things that it's on, but there's no downtime on it. You can tweak it in the
Mm,
AI world to ensure that there's no impact on patient care.
mm,
So it is like there is so light and dark with both sides, isn't it, of what good it can do and what bad. It's just having the right balance. And like you said, I do think it goes back to the consumers and the businesses and things of what we choose to use and pick to use. Where you were saying about yes, we can see the guzzling fuel, right, that comes out. So we may pick an electrical car, potentially a Tesla, whatever you choose to drive. But all those cars are run with software. So unless the software that the Tesla or the Volvo or Range Rover or whatever they're putting in isn't coming from an ethically sourced data center, it's still the same circle, isn't it? You could be driving a really clean car, but if it's been run on an operating system you could just be counteracting, it's a vicious circle, isn't it? So I think you're right of us looking under the hood and seeing how is that powered, what's it been doing, and that is on us. We've made that decision, a lot of us, that we won't buy fast fashion because we've seen the impacts. We won't get into certain cars because of the impact. We won't eat certain foods. We'll eat less red meat because we've seen the impact. And I think the tangibility bit is such the important part. Human beings, unless they can see it or understand it, and really until you started saying, oh, that's the equivalent of New Zealand X, it's just numbers, isn't it?
Yeah.
We can't physically see it.
Yeah, and like we're talking about, there's sort of, it's particularly difficult because you're either talking about really small numbers that people don't really care about. So, for instance, at Crimson, like we made some improvements to our build pipelines, which reduced like our bandwidth usage, and we saved something like the equivalent of like a kilogram of carbon dioxide per week, right? Which is really nothing. Like I wrote a blog post about it because I thought it was interesting, but it's a bit of a nothing burger. And on that end of the spectrum, like people just don't care because it's so tiny. But then on the other end of the spectrum, like you hear this like 7.5 billion number, and two things is like, one, like there's no context to that. Like you don't know, is that significant relative to like the planet's emissions? And secondly, like it's difficult to just wrap your head around like even a single billion. It's a huge number, and people kind of just like naturally disengage when you throw around like large numbers like this, because past a certain level of scale, like they're all the same to our human brain. And so, yeah, like it's a difficult problem because it doesn't have that physicality, and because like the numbers on either, we're generally talking about numbers on the extreme ends of the spectrum, and people just don't have a great way of understanding that because we're not evolved for it.
But it also shows, I know what you're saying, what you guys did was you say it's a small number, but this goes back to the whole of us all making small changes makes an impact. So if everyone that's involved in software or within data centers, or everyone makes that small improvement, we're all doing our little bit. And that's the only way we're going to tackle it from global change in any way. It's not, unless there's some massive legal laws that come in to stop people doing X, Y, and Z, which probably will never happen. It's got to be those, we pick up recycling things, we recycle things. Like, what can we do in our own patch, in our own homes, in our own businesses, that hopefully impacts everyone? Do you think there's things that tech professionals can do to effectively engage with their companies to adopt renewable choices? Do you think there are policies that need to come in? What do you think is a kind of a full round that would get us on the path to being more green?
Yeah, so I think like we're in a uniquely opportune moment, because so if you're using one of the public clouds like AWS or Google Cloud or Azure, each of these clouds will have like some kind of tool in the dashboard which lets you measure the carbon footprint of your infrastructure. And so in AWS, it's called the Customer Carbon Footprint Tool. In Google Cloud, it's just the Carbon Footprint Tool. And in Azure, it's the Emissions Impact Dashboard. And what you will notice if you go to these dashboards and you look at your historical carbon emissions, and then you cross-reference that with your cloud bill, you will find that there is actually quite a strong correlation for most companies between their carbon emissions from their cloud infrastructure and their cloud spend. And that intuitively makes sense because, circling back to the start, like you need energy in order to run software. Less efficient software, less efficient systems are going to require more energy, and energy is not free. as we well know. So I think like there's a lot of energy at the moment in the tech sector on cost cutting. We're seeing that unfortunately in a lot of like layoffs across the industry. But
Yeah.
there is an opportunity to leverage this and make a business case that, like, hey, one way we can cut a lot of OPEX from the business and be a bit leaner is to actually like go back and look at, and review our usage of, cloud platforms, of third-party software vendors, of the code that we've written ourselves. And really like challenge ourselves to think about how can we move the pieces of the puzzle around in such a way that like we minimize our carbon footprint while also delivering like those cost savings. So I think like at this point in time, like that's a really effective message that engineers on the ground can use to get buy-in from like the business side into investing in these efforts. Um, the other thing here, I guess, like there are two other things, conceptual things, and then we can talk a little bit about like some specifics here. Um, the other thing that's like worth thinking about here is, and product people really love this, is thinking about like if you look at your roadmap, um, what features are you shipping over the next quarter, and how might you be able to add items to the roadmap which are climate friendly. So a really great
Okay.
example of this is I use Hey as my email provider, hui.com. And a really small thing that they do is when you delete something from your email inbox, they have this feature called recycling. And so out of the box, like anything in trash gets deleted after 90 days. And you can configure that time period. But the impact of this is like when I delete something, I'm not holding on to it forever. It's not sitting there on disk forever. Generally, these systems are going to have like redundant copies of the data for backup purposes. Like all of that goes away when my trash like gets recycled in Hayes parlance. And there may be opportunities at the company you work at where you can get something similar added into the roadmap, which yields some kind of like climate footprint improvement. At Crimson,
Okay.
the build pipeline improvement we did was making shallow clones of our Git repo as opposed to doing like a full copy. So we only fetch the latest version of the code rather than the latest version of the code and all the history. Um, so if you can tie these feature ideas to like, hey, like we can position ourselves as being climate friendly, like, hey, will lead very strongly with like when they introduce the recycling feature, they always talk about all of this electronic waste that's just piling up in people's email trash cans. So you can position yourself in that way, and depending on your target demographic, like this is a pretty compelling reason for someone to use your solution over someone else's. It certainly played into my decision to purchase
Yeah, who
a
you
service.
chose.
And the last thing is just like challenging ourselves as an industry to really think about the second and third order effects. And this is like a much wider discussion, but I think in general, like whenever I've had a chat with people like at the companies I work with on the business side around like, you know, how does this look like in terms of climate impact? Like, how does this look like in terms of like ethics and our broader impact on society? I think like it's true that companies are looking to, in general, like make the most money with like the least amount of investment possible. But like at the
Yeah.
same time, like companies are staffed by people, and your colleagues are very interested in walking outside without like a gas mask on. And I think like in general, like most people are pretty reasonable about this if you do bring it up. The issue is that most people just don't know about this. Like your product manager, your CEO, they're not thinking about, beneath the veneer of like the shiny app, like what's actually happening in the data center and on the back end. And just like bringing this up and giving voice to it um, is sometimes all you need to do. But certainly at the moment, like in light of like the high interest rate environment we're in right now, lots of effort into cost cutting measures, and there is a very strong correlation between cloud spend and climate and carbon dioxide footprint. And there are, on the practical side, like a lot of really easy, high leverage changes that you can roll out like this week, and build momentum for some of those like deeper and harder engineering lifts. So one example would be circling back to that discussion about Google Cloud regions. Huge, huge, huge difference between LA and Las Vegas in terms of like energy mix. And, picking the LA region at the start of your project is literally just a matter of picking a different option from a drop down menu. It's trivially easy. It's not like you need to drive there and like drop off your servers or anything, right? Like this is all self serve via software. Um, big impacts. Like you do it in like 2 seconds at the start of the project. You just need to Google like, which regions are most climate friendly, like what's the energy mix, and make the right decision there. And then, God, I had something else in mind. Yes. So really easy engineering lift there. You just pick a different option in the drop-down menu. The other thing that like people just don't really think about is you're generally like your production environment absolutely needs to be up like 24/7 because you probably have customers all over the globe. Most companies are going to have at least one more environment, like a staging environment where developers will push code to, test it in that staging environment before promoting to production. Oftentimes there'll be even more environments, like a QA environment or a pre-live environment, so on and so forth. A lot of companies are not, like most companies are not big multinational corporations with people working like 24/7 every hour of the day across the globe. Most companies are going to be hiring like locally or at least within like a specific country or a specific region. And in those cases, like something you can look into is, do we need to run these extra environments, our staging, our pre-live, our QA environment, so on and so forth? Do we need to be running these things in the middle of the night when everybody on the team is hopefully in bed asleep? And in general, like you probably don't. And again, like this is a relatively easy change where all you really need to do is, I'm mostly experienced with AWS, and so I'll use their parlance. You have an auto scaling group on the servers that run your application, and you can set an auto scaling rule to scale down to 0 servers based on the time of day. And when you turn off your staging environment, you save 100% of the climate footprint of these additional environments. So these are two like very practical, simple things that you can do like within the week to get the ball rolling on this and generate some energy. And the staging thing in particular is a very obvious cost saving. So at Crimson, like our staging environment was something like 20% of our cloud spend. And so if you're able to turn that off for 50% of the time, you save 10% on your cloud bill. And nobody's going to complain about that.
It's the same as how we have to consider like we don't leave lights on all day.
Exactly. Yeah.
We don't get out the shower and leave the shower running while we're not there.
Yeah. It's
we can all visualize that and get that. It's exactly the same with tech, isn't it?
Yeah. It's the exact thing. Yeah.
And the thing is, well, those things that we're not thinking about or we think are dormant are constantly just eating. It's like you're saying, oh, well, I hadn't even thought about all my emails and trash that are like taking up energy. That's like it's like my computer, or it's like your TV being on standby the whole time, isn't it?
Exactly. Yeah, it's like
You just don't think about
yeah.
it.
I think like these analogies are really great because I think yeah, like fundamentally, like what we're talking about here is no different from keeping the lights off at noon and at noon. Um, but yeah, it's exactly the same thing, and people just don't think about it because it's not, like I can see a light that's on, but I can't
Yes.
really see the servers
But
running my staging environment.
I agree with you, but I do think it's marketeers and PR and our media
Mm,
side, right? We don't buy fast fashion
mm,
now because we made companies
mm,
accountable for the way that they were
mm,
producing
mm,
factories, who their employees were. We wouldn't stand for it because we'd seen it. We, as a consumer of the internet or an app, cannot see
mm,
behind what's been operated and where it's been doing. And I think that is where, like you're saying, shining a light on this, getting media involved, marketing of like going, well, hang on, how are they operating? Who are they using? Where is it being done? How much waste are they creating? Makes people be able to, it's making the story tangible. And
mm,
and we can only make the right decisions
mm,
once we know the impact. And I think that's why it's so important to have these conversations on the podcast and bringing things to that, because then, we can force the hand
mm.
to make the decisions.
Yeah, absolutely.
And I'm going to go empty my emails now from trash. It's making me feel guilty.
Yeah, very good.
Sophia, thank you so much. You've spent an hour of your time talking about a very, very important topic. Just to close, is there anything else you think that we should add, or ways people can contact or reach out to you, or things that we can all do right now to make a difference?
Yeah, sure. So I have a blog, sophiabits.com, that I will usually write something about green software engineering every now and then. And my contact details are available there at the bottom of the page. I've got an email. I'm happy to for anyone to reach out to me about this topic. Happy to discuss in detail or take a look at the software you're working on and give some advice.
Perfect.
Yeah, happy
Well,
to
thank you,
talk to
Sophia.
anyone
That has
interested.
really opened a lot of things to me to think about, like ethically from a green perspective, ethically from making sure that I'm doing a quiz that's not making me buy something that I don't actually need. Um, probably that's more of the worry. I've got to go through my cabinet of supplements that I probably don't need to be taking. But thank you so much, especially as you're in New York and you're traveling and all different times. And I know we couldn't get this in the first time that we hoped to. So I really appreciate that. So thank you so much. Sophia, have a fantastic rest of the day, and I hope this is only the first time that we speak. I'm sure there's more things that we can discuss in the future.
Yeah, for sure. Thanks for having me. It's been a pleasure.
Sophia, thank you so much for sharing your insights and practical tips with us. It's clear that while the IT industry faces significant environmental challenges, there are also incredible opportunities for innovation and positive change. To our listeners, remember that every line of code and every configuration tweak counts. Together, we can help shape a more sustainable digital future and protect our planet. Once again, thank you so much for listening to this episode of The Core, and I do hope you will join us for the next time.